Good morning, biopsychology class. Uh, I've seen in some of your exercises that there is a bit of confusion between the mechanisms of drug effects on neurotransmitters, specifically the difference between an agonistic drug effect and an antagonistic drug effect. An agonistic drug effect is any effect that increases the responsiveness of the neurotransmitter. So let's go over and then of course the antagonistic drug effect is anything that reduces the responsiveness of the neurotransmitter. So here on the left side of the screen, you'll see that there are 6 ways that a drug can affect the neurotransmitter production, concentration, and reception. And over here, there are 5 ways in which the drug could uh, uh, minimize or reduce the effect of the neurotransmitter. So, first of all, just generally speaking, you might think, well, with all of these different ways in which one can intercede or mediate this effect, then there are certainly lots of ways that a drug could be researched and those neurotransmitter sites could be affected. And indeed, there are, hence the entrance of all of the neuroleptics and neuropharmacological agents, especially antidepressants that we use today. Anyway, we can go through this fairly quickly. Any agonistic drug effect. Here's one process. The drug increases the synthesis of the neurotransmitter. So here, any drug that simply increases the amount of the precursor of the neurotransmitter. Now, most neurotransmitters, most precursors, because they don't come into being immediately, and in fact, they are produced by a sort of a chemical manufacturing facility back here. You see the little spirals here actually represent DNA. Probably those are actually messenger RNA molecules that then produce the drug, put the parts together, and then they're produced. And then here, stored in these things called vesicles, these little reservoirs of neurotransmitter chemical called reservoirs. So here, the drug increases the number of neurotransmitter molecules by destroying degrading enzymes. So there are enzymes also that mediate and control the level and concentrations of the neurotransmitter drug. So if you destroy or decrease the number of neurotransmitter molecules, if you reduce, that is, the number of enzymes that destroy or degrade the neurotransmitter substance, you are then increasing the concentration of the neurotransmitter substance. In this case, back here in the transmitter part of the neuron. Here, the drug increases the release of the neurotransmitter molecule from the terminal buttons, so you can have a greater frequency of release of the neurotransmitter from the terminal buttons, because those are sequence and molecularly or biomolecularly timed, so there's not too much or too little transmitted. So here you can increase the release of the neurotransmitter molecule from the terminal buttons. Here you can bind the drug to autoreceptors that block their inhibitory effect on the neurotransmitter release. So here what you can do is block, in this case, block the inhibitory effect of the neurotransmitter release. Because again, like I said, there are drugs and enzymes that will, in order to mediate the release of neurotransmitter, there are receptors called autoreceptors that the neurotransmitter substance goes into, and it's like a feedback system, like your temperature, so, or the room temperature. So if it gets too too warm, then the thermostat goes off, and if it gets too cold, the thermostat goes on. Well, the same thing happens here, is once the concentration of the neurotransmitter substance gets too high, then what happens here is that you get an autoreceptor that then says, I'm now picking up the neurotransmitter substance that this side is releasing, and now it's too much, so let's slow it down back here a bit. So the next one is the drug binds to postsynaptic receptors and either activates them or increases the effect of them on the neurotransmitter molecules. So here, in fact, you can also have a drug that comes back here and says, hey, this side needs more and more. So it tells the transmitter side that over here we need more and more and more. And here the drug blocks the deactivation of the neurotransmitter molecules by blocking degradation or reuptake. I think this was one of the questions that was mostly, I think maybe half of you got it, a few got it, some, but many did not. And that is just because you have a blocking agent here doesn't mean that it is an agonist. So if you're blocking the reuptake of the neurotransmitter, what's going on? That means you are increasing the concentration of it here in the synaptic cleft, and by doing so, you are then facilitating its effect. So that process is an agonist, not an antagonist. Let's look at the antagonizing drug effects. Here, the drug blocks the synthesis of the neurotransmitter molecule. So in other words, the drug would come up here and destroy the synthesizing enzymes. So let's say, for example, we were producing dopamine up here, then it would block the synthesis of or destroy even L-dopa. Excuse me. Here on the antagonizing side, the drug causes the neurotransmitter molecules to leak from the vesicles to be destroyed by the degrading enzymes. So in other words, you decrease the ability of the neurotransmitter vesicles or reservoirs to hold the neurotransmitter. They leak from it, and then they're destroyed by degrading enzymes. Here you could have a drug that blocks the release of the neurotransmitter substance from the terminal button. So the drug goes in there, and it goes in the terminal button where the neurotransmitter would normally be released, but something's there that's blocking it. So now you decrease the concentration of the neurotransmitter substance here in the synaptic cleft. Here you can, the drug can activate the autoreceptors and inhibit the neurotransmitter release. Now notice that this is just the opposite of over here. Here the drug binds to autoreceptors and blocks the inhibitory effect. Here the drug activates the autoreceptors and inhibits the neurotransmitter effect. And finally, the drug is a receptor blocker. So here you get a drug that goes into here in these receptor sites, and sort of like a lock and key thing, and it goes in here and says there's somebody here already, so it has no effect whatsoever. So now here you get the drug, that is the neurotransmitter substance going into the synaptic cleft. There's already a blocking molecule there, and so the drug the neurotransmitter gets picked up by the reuptake enzymes. Now reuptake can either destroy the neurotransmitter substance that's out here, or it can literally reuptake, which means that it comes back and it sends the neurotransmitter substance back into the button and recycles it essentially. So that's it, the mechanisms of drug effects and the mechanism of neurotransmitter substances. I think that's a very important issue to understand, not necessarily the biochemistry of neurotransmitter substance, although of course that's an extremely important point to understand as well. We're still just getting into that, because we find that a lot of the biochemistry of the neurotransmitter substances is general. That is, if we can affect one specific neurotransmitter in some specific neurological tract, let's say a dopaminergic tract or a serotonergic tract, or a acetylcholine tract, that there's also side effects, and it's not just simply targeted to that specific area. So there's still a lot to learn generally in this area of research, but it is coming along. Anyway, just hopefully this video cleared things up for you. And otherwise, you guys are doing just great. Keep up the reading, please. That's very important, and keep up the exercises. And understand as you do these exercises that the point is not just to turn it in, but to also understand what's going on in the concept and the area of study. So thanks again, and I'll talk to you later. Bye.